Welcome to this video about how to start to work with the Keil MDK. First of all, you have installed Helix Core. So start Helix Core by pressing the start button and type PV4 and then start it. Oh, press enter, and I already started mine, of course. And I have a lot of subdirectories, but you should have this one. SR2 assignments, and then here test project, which contains several files. You have to download this to your laptop, and for that you'll press the right mouse button and you'll say get latest revision, and then it should say 8 files added. In case that it does not add any files, you could do the following: right mouse button and then say get revision, force operation here, and then say press get revision, and in that case it will override any files already there. Okay, these files are now in your workspace, of course, and I have more already, and you will get more also at a later stage. Here's your test project, and this is your project itself. You can double click here or go to the proper position here, which is your workspace on your laptop. I'll do it from here. Double click on the project X file. It will start Keil, and then you can open most of the files needed, and you can ignore this here, but you should open the main.c file by double clicking on it.
This is the environment, complete environment that you will be working with a menu with several options. This is what we call the project tree, where your source file will be stored under sources, and some output windows below. And we can use this also to debug our software, which means that it will be compiled and then the laptop will perform as if it is the target chip where the software should run on in the future, and then you can test your software, find problems, etc. Okay, normally you will type your code in a file and save it somehow, and we'll get to that in a later stage. What does this program do? It has some variable. It has the main program, and the main program is, or the main function is where a C program always starts, and we have some kind of loop, and in the loop we will increment test every time as fast as possible. So let's first build it. We can go to project, and we can see here build or rebuild. And build means that the compiler does it in an intelligent way, which means only files that have been changed will be built. And rebuild means throw everything away that has been built already and do it from scratch. So I'll take this one for now. And when it's ready, come on, you will see that it has done several things. It tells you which compiler has been used. This is the version 506, the one that we have been installing. Which target, this is the target name that has been built. Some other files that are hidden somewhere, but here we see that our main.c, which is this code, has been compiled, and some other files. And then at the linking phase it will put everything together, and in the end it will produce a file integer.axf, and it will show you here errors and or warnings. And you can only start debugging when you have 0 errors. Well, let's introduce an error somehow. I will remove this semicolon and just do, in this case, a build again. And as you can see now, it says error in main.c line 15, which is that line. It is expecting a semicolon. Well, I can see it up here, of course, but these crosses in the editor window are not always synchronized with what is happening during the compile phase. So let's just double click on the line here, and then the cursor will be put at a position where the compiler found the error, and I can see that it's working. I put my cursor here, I double click again here, and it tells me there is my error. Well, when you're tracing errors this way, you have to remember that the error is present exactly at that position or just one position before. And when I press my left arrow button, you see that the position just before the starting of that line is of course the end of that line, and it tells you also here from the editor window, which is that it expects a semicolon, which is true of course because I just removed it. So this way you can go from errors or warnings of course being shown here, double click on it and it will position the cursor at the proper position or just after the position where the error has been detected. So I put my semicolon back, I'll build it again. Of course my program is okay now, and there's now a way of testing my software. So we are going to test it using the debug menu, and as you can see we can start and stop a debug session by clicking here or pressing Ctrl F5. Well, let's do this, and then it will open the debug view. Well, you can close the register and disassembly fields because we don't use it. Here you still see the tree, so you can navigate between different files in the future. And as you can see, you see here some kind of special cursor which tells us that the program has been stopped in main at this line. Below you see here some stack information which is useless for you right now. This you can also ignore. But a very useful feature is the fact that we can watch variables. So let's open a watch window, and I still have some old stuff in here. Just select it and press the delete button to remove them, and then we can enter our expression here. I can type it of course, or I can just say Ctrl C copy, Ctrl V paste, enter, and then it will show what the value is of test. Well, this is a hexadecimal display. Just remove the tick here and it will show a decimal value. Okay, so what we have now is our debugger is ready to start from here, line 12. We can inspect our test variable, and now we have to run the program somehow. Well, we have different options here also. We can run it and then it will just run and keep us more or less uninformed of what's happening. And we can step or step over. Well, step F11 says that we can step into functions. Main is also a function, but we will get to functions later. And step over steps over a function. For now, let's use F10. So I'll press F10 and you see that this instruction or line of code has been executed, which is indicated by the green square. And now the cursor is positioned here so that the debugger tells us the next line I will execute for you is this one. So let's press F10 again, and it has executed the increment of test. As you can see, one has been added. And when I press F10 again, it says, well, I don't have to go here because now I'm in this loop, so I will never end up here again. And every time I press F10, you will see here and once again that the program is running. When I press F5, which means run, it will update here, and here I have the possibility to temporarily stop it again, and it will of course stop at the same line and show us what the current value is. and by pressing F10 it will increment it step by step again. Okay, that's it for now. You've learned enough to make your assignments. Thank you.